Okay, let's continue on. Example number 7. Find the global extrema of this equation on this interval. So first off, let's check extreme value theorem. Is f continuous on this interval? Well, this is a cubic, so that's not going to have any holes, it's not going to have any jumps, it's not going to have any asymptotes. So yes, we're going to say yes. Now let's do it with black. Yes, f is continuous on the interval stated. So the extreme value theorem applies, which means we're guaranteed to have an absolute min and an absolute max. So what we need to do is find them. And we find them by using the candidate test. So step 1, find all critical numbers in the function. Find all critical numbers. And remember, critical numbers are either where f prime of x equals 0 or where f prime of x is undefined. Those are our critical numbers. So let's start by finding f prime. So take my derivative of this. Looks like put the 3 in front. We'll cancel, so I just have x squared minus 4x. Should be our f prime. So let's start with where it equals 0. So let's factor out that x. And then we set them both equal to 0. So we get x equals 0 and x equals 4. So those are our first two critical numbers. Now let's see, our second one is where our f prime is undefined. Undefined basically means anywhere you have a denominator that equals 0. This one doesn't have a denominator, so there's no undefined critical numbers for this problem. So step 2 of the candidate test is we're going to test all the candidates, or the critical numbers, which I'm going to start shortening to Cn. So testing the critical numbers means plugging them in to f of x. So I'm going to do f of 0 and f of 4. Now, wait a minute. Let's go back and look at that. Find y values at each critical number and at each endpoint of the interval. So I also need to include f of -1, my endpoint, and f of 3, my endpoint. Which means right now 4 is not in our interval. So it is a critical number, but because it's not in this interval that we're focusing on, it doesn't count for this problem. So we're going to test these numbers, plug in the critical number and the endpoints, see what we get. So 1/3 times -1 cubed minus 2 times -1 squared, plugging it into f. I'm just going to do them all at the same time. And then you can just plug those into your calculator. You should get -7/3, 0, and -9. So now we can say, remember we're trying to find the global extrema or the absolute extrema. Those mean the same thing, global and absolute. So the global max of f is, and it doesn't ask for a point or an x value, so we're just listing the y values. So the biggest y value is 0. And the global or absolute min min of f is the very smallest y value, -9. And those are our answers. That's it. And you'll notice the extreme value theorem held. Because it was continuous on this interval, we were guaranteed to have one of each. Sweet. Okay, let's try this one. Absolute max and absolute min. Okay, so this one, first off, make sure that it is continuous. Yes, f is continuous on 0, 5, check. So then we need to do our candidate test. Step 1 is finding our critical numbers. So where f prime of x equals 0 or undefined. Now, finding f prime for this one is a little bit weird. And here's why. Because we don't really have ways to find the derivative of an absolute value. So we're just going to do this graphically. So remember, that would move it right to, go back to our transformations. So then my graph should look like that. So this is the graph of f of x. So that means, remember, f prime is your slope. So this way looks like our slope would be -1, down 1 over 1. And this way, our slope is a +1. So that would mean there's nowhere where f prime is 0. However, there is one spot where it is undefined. And that's right there. So f prime of, let's see, that's 2, right? F prime of 2 is going to be undefined because it's a sharp turn. And remember, we can't take a derivative where there's a sharp turn. So it was kind of, you can't really do that algebraically, but sometimes you can just find those critical numbers by graphing it. So the derivative's not going to exist there, so it's going to be undefined. So step 2, we need to test our critical numbers and endpoints, because we're looking for an absolute max and min, and we should be guaranteed one because it is continuous. So we're going to find f of 0, that's our endpoint, f of 2, that's our critical number, and f of 5, that's our endpoint. So we plug these all into f. So here I'd get absolute value of -2, which is 2, absolute value of 0, which is 0, absolute value of 3, which is 3. So now I can state my, let's see, in this problem it uses absolute, so we should probably keep the same wording. Okay, sorry, I had to pause for a second, come back. So we've got our answers right here. The absolute max of f is 3, because that's the biggest y value. Absolute min of f is 0, because that's the smallest y value. So in the next video, we'll do 2 more examples of problems where we test this out and find these absolute extrema.